So onto our presentation, multi-cloud detection and incident response, practical lessons from a Fortune 500 security leader. Today's presenters include Andrew Tabona, Senior VP of Threat Management and Incident Response for a Fortune 500 financial services firm. Andrew's joined by Ron Konigsberg, CTO and co-founder of GEM Security. We're going to kick things off with a poll of our audience. Let's advance to that. Let's see. How many cloud providers are currently being used in your organization? Some of the examples include AWS, Azure, Google, QCI, Alibaba, etc. Andrew and Ron, I'd like to bring you in here. I'm guessing, wondering if you have an idea of how many these respondents will pop up among our participants here.
I think it will share mostly the blend of the audience. So if we see large enterprises, I would assume we'd see more on the Azure side. If we see finance, banking would see more GCP, and the general tech would probably lean more into AWS. So I'm not sure. I would expect AWS to lead, but interesting to see the results.
Yeah, same. I think also there's a regional aspect to this as well. But if you look at like the market share, I think AWS and Azure will come out on top here.
So are you anticipating that most of our audience will skew toward the 3 and 3+ end of the spectrum?
I would assume so.
I would say at least 2.
Yeah, sure. We'll give our audience just a couple more seconds. All right, why don't we see where people checked in here?
Interesting.
Andrew, Ron, what do you make of this? Are you surprised by the 2 is clearly leading the pack here?
Yeah, I have a lot of follow-ups, but I would assume the predominant set is Azure plus AWS. But that's interesting. But it's a one-sided poll, so I don't have all the answers.
Can't interview the participants. Well, we have a second poll as well. We're doing a lot of temperature taking here today. How many cloud security incidents have you experienced in the past 12 months? If our audience could weigh in there with their responses: 0, 1, 2, 3, more than 3. Andrew, what's your best sense of how this will look when we pop over to the results?
I think it really depends on how honest people are feeling today. I mean, I would be surprised if there wasn't at least 1.
Sure.
But again, it depends on the organization, the size, the detection capabilities that people have. So, yeah, I would say at least 1.
Yeah, there is also a definition of cloud, right? So it can be people only thinking about the cloud provider, like the previous poll is leaning into, or is your IDP also considered a cloud incident? In my opinion, it is. So if it includes your Okta or Microsoft Entra, formerly AD, and then the number definitely goes up.
All right, I'm going to pop ahead then to the results for our second poll. Andrew, Ron, is this about what you expected?
Yeah, you look at the split, so at least 1, and then 20% plus 3+. So, yeah, I think it just shows that people have cloud incidents, and you know, there's definitely a need for something like this today, I guess.
Yeah, I also wonder about the 33% because it's like the statistics that I know are more about like roughly 80% of organizations experience a cloud attack every year. So it is pretty close, right? 70%. But I wonder if it means that like they're super protected or if they have blind spots. So that's something like if I would be part of the 33%, that would be interesting to take this session and think,
Sure.
do I see everything? Am I just in a good state or do I have blind spots?
All right. Well, we have a better sense of our audience now and what their experience is. Let's formally kick off the presentation. Andrew, I'm going to hand the floor to you.
Terry, thank you very much. Not advance the slide here. So thanks for having me and thanks for the opportunity. I appreciate everyone's time. It's quite humbling to be here to share my thoughts and experiences of my journey as I lead the cyber incident response team, the threat intelligence and red team functions at a Fortune 500 financial services firm. So I mainly deal with sort of the strategy, where are the gaps, program management, incident handling, and things like this. I've seen a rapid shift to the cloud. The footprint just ballooned, and especially this year with the advancement of Gen AI. And I bet you were thinking, I'm not going to hear Gen AI again on this talk, but I just had to mention it because it's the truth, right? Everybody's jumping on the Gen AI bandwagon, and to get there quickly, you need things like the cloud to spin up that infrastructure and create that architecture pretty quickly. So you see, like dev teams, they wanna innovate. They want the autonomy to do what they want to do when they want to do it. Then you get your marketing and sales teams. They want to be first to market. The cloud enables this, right? But at the same time, as you all know, it comes with risk, increased risk. There's an increased attack surface, evolving threat landscape that focuses on targeting your cloud resources. I mean, think of Tesla in 2021 is a famous one, right? Or earlier this year, is it Medibank in Australia? Those are just two high-profile examples, right? So what I'm going to do today is, firstly, I'm going to try level set on the differences between on-prem and cloud IR. Then I'm going to give you some things to think about when it comes to detection and response in the cloud. We'll briefly touch on CSPM and how that's different, because I hear this all the time, right? Like people say, oh, we have a CSPM, so we're good, right? Not really, but we'll delve into that a little later, right? And then I'll round off by giving you some takeaways and some lessons that I've learned along the way on how to prepare for cloud incident. Just stuff that's worked for me. Before we close off, obviously, I'll turn it over to Ron then to give his thoughts on how GEM Security is thinking about solutions to these kind of challenges that we're facing with detection and response in the cloud. So there's this common misconception, at least in my view, that people think, I have a solid IR plan for on-prem, so we'll just take that and shift it to the cloud and just use it for cloud incidents. No, it's actually vastly different. And unfortunately, it's not just a straight lift and shift, right? So the principles of IR obviously remain the same, right? You think of the life cycle, preparation, detection, analysis, containment, etc. That remains the same. But the way that you do things and how you prepare, the logging and the telemetry that's available to you, those things are different, right? You think about the scale and complexity of clouds, of CSPs. There's hundreds of services. I was in the AWS console the other day, and I was just curiosity. I was just going on the left-hand pane and saying services. There's loads of them, and it feels like new ones are coming out each week. So it's hard to keep up with the scale and complexity at times. Again, and developers want that autonomy to try these new services immediately, and the freedom to build environments how they want to build them. So there's, of course, architectural patterns and standards obviously help, but developers take shortcuts, right? And that's no way dissing developers, but this stuff happens all the time. You remember a few years ago how many cloud storage exposures we had because people used to click next, next, next on that security group wizard when they're creating an EC2 instance before AWS came out and fixed that a few years ago. And then you think of log sources, right? The way that logs are formatted and analyzed across the CSPs is different. So there's a lot to try and keep up with when it comes to analyzing that sort of space. So Azure, you got JSON format, you use KQL to query it. GCP is also JSON. You got that Logs Explorer. AWS uses log streams. You got CloudWatch. So it's kind of like you get used to one, and then you got to shift to the other. And then of course you think of microservices and functions as a service, auto scaling, and things like this. The logs are up and down within minutes, right? So those services are going up and down, sort of generating those logs. So you only get a few seconds of activity or maybe nothing at all. And finally, I just brought it up here with the forensic side of things, with on-prem forensic, like traditional forensics, and that's my background, right? All the artifacts, or most of the artifacts you need, are generally in one location. So you'd get write blocker, you take an image of a server, a laptop, whatever, take it back to the lab, analyze that image, and for the most part, you can create a decent picture of what's out there, or what's happened, right, in that situation. But with the cloud, it's different, right? Obviously, resources are spread all over the place, regions, availability zones, and within the different services themselves. So most tools I've seen, and they're getting better, but most tools I've seen aren't really built for the cloud. They still rely on that sort of capture and take back and analyze that image. So there's not real sort of true support or full support for cloud resources. And then not forgetting, right, the way that cloud is architected with your IaaS, PaaS, and SaaS. The higher you go up in the model, the less control you have on what and how you can forensically analyze those artifacts. So lots of changes and challenges there as a forensic analyst or a DFIR analyst, or for your cloud security teams. But there are some benefits, right? There's some good stuff, of course, with the cloud. Everything from serverless services to data to VMs, everything can be monitored through the cloud's control plane, APIs, right? So there's no real need for agents, especially in logging and monitoring purposes. The control plane is actually continuously pulling log events from different services versus an agent that's periodically pushing stuff to, say, a central location like a scene. And then, of course, some services like RDS, you can't even deploy an agent to them. So that brings us to services like, say, Azure Logic apps or Amazon Event Bridge. They're kind of all these off-the-shelf, ready to go, and they make it as easy as possible for you to integrate and build through the use of that API architecture. One of my favorite things here is infrastructure as code. Things like Terraform, CloudFormation, the CDM in Google, Resource Manager in Azure, whatever. It makes deploying environments within a matter of hours possible. So I like this from a recovery/remediation perspective on the IR side of things. Say you have an incident which requires you to rebuild part or all of your environment. Using IAC, you save a whole bunch of time and operational cost, right? Or say, and this I've done as well, and I love it. So you're running a purple team exercise, and you want to create a replica of a prod environment, say in a sandbox account. You could do that pretty quickly using IAC. So that's really, really good, and I recommend that. So considerations. These are some of the things that I would think about when you're preparing or sort of shifting to that mindset for cloud incident response. It's one of the big questions that I always find is around who needs to be involved in the planning of the detection. Firstly, like, who owns this space? Who can contribute to us as an organization creating a good detection? Is it cloud security? Is it threat or threat intel? Is it security engineering? Is it the business? To me, it's all of those groups, right? Everyone has a part to play, because you get the business context, you get what's our threat profile looking like, what's the latest threat intel we have about new attacks. You have cloud security folks who know, the IAM policies inside out. You all come together and you contribute towards making that detection. And then, of course, I've got it here, like, what telemetry should we collect? What artifacts will we have to highlight anomalies in our environment? How many logs should we collect? Where should we keep it, right? You could pipe it all to a SIEM, but things are going to get very expensive very quickly, especially when you think of things like, say, VPC flow logs, right? Like net flow logs. Maybe use a lower cost data lake so you can capture logs you wouldn't otherwise be able to capture, right? And then one big question is, how long should we keep it for? And if you come from an organization that has deep pockets, maybe you say, let's keep it forever. I mean, unfortunately, not everyone has that luxury, but even if they did, personally, I don't think that's a brilliant idea anyway, especially in a regulated environment. And here I'm thinking of liability when it comes to discovering or discovery or discoverability of those logs, right? Like, the longer you keep it, the more discoverable you make it in the long term. So you kind of, from a legal context, want to only keep what you need to keep for as long as you need to keep it, or as long as you're mandated to keep it, and then just, use a retention policy to get rid of the rest. So the way I would do it is this: assess what you're needing to protect. Look at what cloud native and third-party controls you have in place today. Look at what logging those controls can give you. And then, like I mentioned earlier, what are the associated risks or threats to your specific organization? So, like, do some threat modeling, right? Then you collect what you need to collect. And of course, keeping in mind that there's some logging that's disabled by default, like I'm thinking of data access logs, for example, across the CSPs. And then the fun starts. Then you start modeling your detections based on TTPs, right? Known TTPs, and MITRE is brilliant at that. Just look at the cloud matrix there, and talk to your threat intel guys. Then behavioral anomalies. Look at what's patterns of behavior rather than just static indicators. And also think about environmental norms. So, for example, in your environment, if you should never or would never spin up a GPU, then the second that happens in your environment, trigger a signal for it, right? Trigger an alert. Because that's an anomaly that shouldn't be happening in your specific environment. And personally, I would rather know about, say, an IP address from a country that's never logged into your environment before, using an access key that's been static for 3 months or never used for 3 months, and immediately starts enumerating a list of resources, i.e. doing discovery, a few seconds after successful authentication, versus 5 alerts that tell you, hey, you've been port scanned. by an external source, like banks, but we're port scanned like all day, every day. So that doesn't really give me anything, right? So it's coming on to sort of fidelity, which I'll talk a little bit about later on. But that's the thing with detection engineering. You might have the smartest detection engineers around, and there are some really good detection engineers out there. But as an organization, you need to ask yourself, like, can you really keep up with churning out those detections at a rate that keeps up with the threat landscape? And no, that's tough. And like if you're like us, and if you're like most organizations, and my peers I speak to in the industry, it's probably putting a strain on your organization. So, it's hard to get detection maturity on-prem, let alone in the cloud as well. So it's a long journey, it's a multi-year journey, but you need to think about that when you're having these kind of conversations around detection engineering. Similarly, when it comes to alerting, right? What's your signal to noise ratio? The last thing you want to do is like churn out a bunch of alerts that just don't make sense. You end up creating noise, you end up killing the SOC, basically. You create a lot of alert fatigue. So personally, I would always argue it's better to invest time in creating a high fidelity alert than a dozen alerts that have little to no value, right? Just because we need some alerts, right? And then this is your mindset shift as well. I mentioned earlier that cloud versus on-prem is different. So it's worth thinking about your investigation and response to cloud incidents and how that's going to change, because it will change. So do we have the right contacts in place? How do we engage the CSP? Who's our account manager? Do we have SLAs in place? Who's controlling what and who does what, right? These things are really important to ask yourself, because in the middle of a cloud incident, you don't want to be frantically saying, oh, like, who do we call? Like, are we allowed to do this? How do we do this? Like, that's preparation, preparation, preparation. And one thing, and the next thing is like a bit of a cliche, right? But there's research out there, and ISC Squared talks about it as well, like 3+ million jobs in the cyber market, and do have the right skills. There's a shortage of talent, etc. But when it comes to cloud incidents, it's something I feel, I've asked myself as well as part of my organization, do we have the right skills in-house? And I talk to folks who actually do this day in, day out, right? The CrowdStrikes of the world, the Mandiants, etc. And sometimes even they are left scratching their head when it comes to, responding to cloud incidents. So trying to keep up is hard. That's what I'm trying to say. So I would think about a continuous pipeline of training, and that's hands-on and theoretical training, like master the fundamentals, and think about what training you should prioritize, right, for your incident responders and your SOC staff. And then think about a retainer. So do you have a retainer in place with someone who specializes in cloud incidents and can back you up, right? Because again, you could be an awesome team, but sometimes you just need extra hands on deck, or a special area of specialization, right? So maybe you do Azure and AWS, you know them like the back of your hand, but you're a bit rusty on GCP. You have a GCP incident tomorrow, you're gonna need that help, right? You're gonna need that backup. So I would really think about these kind of things. A little word on CSPMs. And the reason I mention this is because I got this asked a couple of times when I started floating the idea of a CDR, and I was looking at what's the next stage in our response maturity, etc. People would say, why do we need this when we have a CSPM in place? Doesn't that cover us? Like, aren't we good in the cloud? And my response is really hygiene versus detection. So a CSPM, they're actually designed to identify misconfigurations, deviations from a set policy. And it's really about sort of proactively tightening the cloud attack surface. And this is good, right? In no way am I sort of dissing CSPMs. They have their place. And it's very, very good to be proactive. But don't fall into the trap of thinking that you're okay because you have a CSPM. What they don't do is give you that near real-time attack visibility and ability to respond. So like investigate, contain, active cloud incidents. That is where a CDR comes in. And by the way, I say near real-time attack visibility because obviously there's a little 5+ minute delay for log ingestion and processing that comes naturally as part of the cloud, right? On the same lines, when you're investigating a detection, I would say context is critical. So, there's been times in the past where we've spent far too long on figuring out, like, what is this resource? Where does it live? Who does it belong to? What does it sit behind? What policies are attached to it? Et cetera, right? You have to look in like 5 different places to try and get the answer. You have to call Bob or Alice to try and figure out a bit more context about that account, especially in very, very large environments. So when you're conducting that initial triage, I would say this context could mean the difference between determining if something is bad or benign within minutes or God forbid, hours. And like I say, I've been there, but it's not nice to sort of knock on people's doors at odd hours of the night just to ask them a silly question like you should have the answer to within a platform that your IR and SOC teams utilize, right? So it's just about trying to put those pieces of the puzzle together in the easiest way, the quickest way, because that gets you started, right? That's, is it bad or is it good? Or is it bad or is it benign? And lastly, I have to say this, right? Like the statistics sort of differ. Sometimes you see 66%, sometimes you see 80%. But the point is that the majority of cloud-based attacks these days, they start with a stolen identity. And as we know, these days, an identity is more than just a username and password. Extend that to secrets, API keys, authentication tokens, and so on, right? They often end up being stolen through whatever, credential harvesting, cred stealers, publicly exposed repos, and so on, right? And I know some CSPMs, they have identity modules, which look at your IAM configurations and suggest ways to tighten things up, and that's good. But again, they don't give you visibility into active identity-based attacks. And that's where I feel this is important to make that determination. And finally, this is, I'm hoping you get some takeaways from this as well. This is some stuff that's worked for me and some stuff that I feel like people should think about when it comes to preparation. So I mentioned sort of containment or speed is essential when it comes to containment. So you need to have, or I suggest you have, a predefined process or a RACI in place, an understanding with the business regarding how much the IR team can do with their own ability and their own decision to put the fire out quickly, right? So in your playbooks, you would have who is responsible for what. And you would agree to that ahead of stage, ahead of the game, right? So like DevOps, for example, you guys can help us gather logs and rotate compromised keys, for example. App owners, you can give us the business context about what that app or that environment is. The IR teams, you can stop the bleeding through agreed methods like killing active sessions or setting a denial policy on the role itself. You perform log analysis, forensics, etc. I just sort of lay it all out, right? Because the last thing you want to do, and I've been in both situations really, but the last thing you want to do is see a fire and not be able to put it out, or have to call like Bob or Alice again. And sorry, I keep using Bob and Alice as a, from crypto, right? Alice and Bob. So if your name's Alice and Bob, forgive me. You don't really want to be calling Alice or Bob at 2 a.m. in the morning, asking them to log into the account so you can take action. It just slows you down, and it's frustrating as an IR analyst. Again, on the flip side, you need to be conscious about business ops, right? You don't really want to be shutting down a VM willy-nilly. It's something that costs the company $100,000 an hour, or at least you want to have that agreed ahead of time. So I think always having that balance between keeping the business going and actually stopping the threat is tough. And personally, sort of off the record, and I'm sort of saying this, my team knows this as well, but if you don't have that access, or you do have the ability to take containment actions, if I had a choice between putting out a fire that potentially is going to result in reputational damage or could end up costing the organization hundreds of thousands or millions of dollars, versus letting things spread. Even if I don't have that predefined agreement, I'm going to do it. Like, I'm going to do it, and I'm going to ask for forgiveness later, because the majority of the time you can justify your decision. And if you know what you're doing, you can justify your decision and say, I'm sort of doing this to alleviate the need for disclosure requirements, blah, blah, right? So I'm going to limit that damage. And then on the same lines, right, make sure you have adequate privileges to analyze, contain, and eradicate. So you should have a read-only account in place for your IR and SOC teams, and some form of just-in-time access, whether that's a break glass account with elevated privileges, or, for example, pre-built Lambda functions that give you access to do those containment actions, for example. Again, it saves you a whole bunch of time, and it stops you from having to chase down those account owners. Something I found that's really beneficial is the concept of purple teaming in the cloud. This has been really successful. So you pick a line of business that has a decent cloud footprint. You ask if you can work with them, say in their non-prod environment, and you sell it to them as, I'm wanting to identify security control gaps. I'm wanting to help you sort of close some risk items you may have within that environment, right? It's also an opportunity for you to strengthen your posture as an organization and train your SOC and IR folks. Like, the amount of times I've seen, like, we've done something at the start of the week, people are really rusty on a certain service or aspect of logging. By the end of it, they're like, they know it pretty well. So that's amazing. So it's a win-win. And it takes me on to my last point around playbooks, predefined playbooks. And this is where they come in. And I mean the two aspects of playbooks, right? So human readable playbooks, like those ones where they have the nice flow charts and diagrams and steps to take, and it's all laid out nicely, right? So if somebody asks you, do you have a playbook for this? Yes, you can give them that PDF or whatever. But also more, I would say, or most importantly in this case, as it relates to the sort of cloud IR, automated or semi-automated playbooks that either run by themselves when certain criteria is met, or when a SOC or IR analyst presses a button. So I mentioned Lambda functions. Make sure you have things like the ability to create an EBS snapshot, or start and stop an instance, isolate traffic, whatever. I found it helps to reduce human error, and your turnaround time on taking that action reduces significantly. And if you're not kind of comfortable from the get-go going with full automation, then do it in a stepwise process. Right? Do semi-automated, i.e. the analyst has to say, okay, I want to click the button and do this. And then over time, you can identify trends where you say, okay, 99% of the time, when an analyst clicked the revoke sessions button, it had no business impact and it was working and it helped to contain the incident in a couple of seconds. That's a really nice business case to then take back to the business and management and say, we want to fully automate this. So that as soon as you see certain criteria, then you trigger that automatic playbook by itself. That's what I had for you today. Again, thanks for listening. I really hope you've taken something away from this. There's more to come from Ron. So I'll hand it over to him, and obviously I'll stick around for Q&A. So Ron, over to you.
I think we have a poll in between. So I will start with the poll first. And then, cool. Terry, are you managing the poll?
Yeah, let's head to the poll. We're asking our audience, what are your top 3 challenges regarding cloud detection and incident response? So we are looking for multiple responses here. Just to go through these: lack of real-time visibility, and ability to promptly remediate ongoing attacks, complexity and time required to investigate alerts by analyzing multiple raw cloud logs, difficulty in hiring and retaining team members with multi-cloud security expertise, high cost of ingesting cloud logs into our SIM, organizational silos between DevOps and SecOps teams. Quite a number of options here. Again, we're looking for what your top 3 challenges are with regard to cloud detection and incident response. Ron, if you're a betting man, what do you imagine will lead the pack here?
So I think the choices are also challenging because they're quite complex. But in the end, we see a lot of gap with hiring for the cloud, so which is option C. And that's one thing. Cost we see as something that definitely occurs, like cost of cloud logs versus the SIEM, but I'm not sure that's like the top challenge. It's like an organizational challenge. I think it's mostly the complexity, the vast amount of sources, and the hiring. That's what I see, at least from my customers.
Sure. Well, let's give our audience just a couple more seconds to weigh in here. Again, we're looking for multiple responses on this particular poll. What do you think, Ron? Should we take a look?
Come on, I'm ready.
So it's this real-time visibility issue that is clearly the big challenge. This is a regular ongoing issue in security management, reactive versus proactive security. Ron, you can't be completely surprised there.
You can, and also the last one, by the way, the difficulty to create detections with minimal noise, and it talks about what Andrew said about the challenge with fidelity. So it's pretty cool. Awesome. So should I go to the slides? Great. So I will try to give some overview to Gem. Keeps jumping to the poll. Let me see. Cool. Hopefully it will stick. Okay. So in general, I will share obviously my perspective, which is it's built from working with multiple organizations of different size, from Fortune 500s to highly regulated, born in the cloud unicorns that face, by the way, very different challenges. And also from our experience, we founded Gem from the trenches of one, building in the cloud, and two, doing incident response ourselves and seeing like the challenges with responding to cloud incidents. And hopefully that would be insightful as well. And after that, we'll do a short demo of what we're building. So we spoke about the fact that everything changes in the cloud. The first thing that I see is identity. The identity in general is challenging. The issue with cloud is that identity is very powerful. You have a central control plane. It generates multiple paths for period escalation, lateral movement. And also, it's simply different. If you think about on-prem, the most prominent path was, at least for Microsoft, it was Active Directory. So that's the equivalent. And each cloud, especially we saw that most organizations use two in this talk, have different primitives. So IAM on AWS works very differently than Microsoft Entra to that sense. So we see identity is super challenging, being powerful, complex, and the key, we call it the keys to the CSPM kingdom, the ability to do everything. Second is scale. So we see many types of services in the cloud. That's one element of scale. The other one is huge log volume, and together they create a challenge. One, how do you handle like that volume and that level of data that you can work with? How do you keep high fidelity with that? And also, how do you chase all these services that are being released over time? And also, the scale of the environment and the scale of people that are changing the environments leads to the fact that actually just maintaining the current state, if you think about an organization in the scale of Andrew's organization, there isn't a single person that really have the architecture of the current architecture of the environment at a single point in time. It's simply impossible. And lastly, automation. There is a lot of activity. There are resources that are auto-scaling and that are ephemeral, and that are a lot is fast and a lot is serverless. That creates challenges, and it's heavily used by devs, but I would say it's also heavily used by attackers that leverage the same automation because it's convenient, and because it's, by the way, it's also an easy way to go under the radar. So these are the main differences as I see them. Moving on, so we talked about the landscape that is changing, what's happening to cloud attacks, and in general, what we see broadly, and of course the details change a bit. If it's an APT or an advanced attack that is already targeting a specific org that was identified as a heavy fish, versus something that was scanned on a medium-sized or small enterprise. But in general, what we see is that attackers are living off the cloud. They are leveraging the cloud capabilities. For attacks, it's identity-centric on their side, and they use a lot of APIs and native features exactly as the cloud is built. The cloud is identity-centric, the cloud is API-based, the cloud has a lot of native capabilities. We see that cloud attacks are very fast. We talk about from entry to discovery within minutes, and to that, from that to period escalation impact. Some service in 10 minutes. For complex organizations, we see something closer to half an hour or an hour. But why is that? It's because it's fast, it's semi-automated, and it's very similar to dev work, both in terms of the capabilities and with the ability to evade defenses. We saw something that was intriguing for me, which is Andrew spoke quite a lot about this program. And what we see that makes the difference with organizations that are able to progress is measuring what matters. And that's something that we think about also as we build our solution, honestly. What can you measure that would allow you to really ensure you're improving, especially when we speak about detection response, it's not always easy to quantify your status. And we look at it in a few lenses. One is real-time visibility, meaning are you able to really see what's going on in the environment from the data that you get? MTTR, so the time to acknowledge an alert, the time it takes to triage and investigate, the time it takes to resolve an alert or to respond. Can you respond and contain even? And the fact that you can show improvement over time. So that's critical aspects here, and something that we see our customers investing a lot in. And simply choosing either all of them or some of them and measuring them generates a lot of improvement over time. In terms of what we do, we try to solve or provide tools to answer each one of these different metrics, I would say. So we are flagging blind spots that exist in cloud environments, mostly real-time visibility gaps of things that you need to see and you're simply not seeing. So can you answer the question today, what are your blind spots in cloud environment? Do you know which logs you're not collecting and which attacks essentially you're exposed to? Detect, so providing this coverage of high fidelity detections with wide coverage, and it's a challenge because as coverage expands, noise obviously also rise up. So how can you detect with high fidelity in a way that wouldn't kill the SOC? Response, the ability to build investigation timelines and stop attacks and get the full context fast enough. And lastly, uncover, which is when something bad really happens, so to capture forensics, snapshots, and get to root cause analysis. We see with detection response, and I saw some questions already from the audience on that on efficiency, being part of the workflow of the team is critical. So a detection response tool has to integrate with what you use. Otherwise, the SOC has more feeds. The company may be F cloud, F on-prem. You get alerts from other tools. So the ability of that tool to be part of that is essentially critical. And also, assuming you have more tools, you have threat intel, you have a CSPM or a CNAP, you have a CI that is working. So being integrated to the cloud environment on the one hand, to the developer environment, and to the SecOps environment is critical if you really want to achieve success and to embed it in the organization. And with that, I will jump to a live demo. I will skip the slides and try to have something like a 5-6 minute demo, so we have time for the Q&A. Perfect. So I'm sharing my screen, and with that, I will not see the video. Terry or Andrew, can you confirm that you can see?
Yes, we can see your shared screen.
Perfect. So a very quick overview of GEM. We start with the dashboard, which is essentially measure what matters. We can see an overview of detected threats, some metrics on stats related to response improvement over time, and also the incident readiness score. That should give like a CISO overview of what's going on. How good am I? How good am I compared to the benchmarks? And am I improving over time? And also what's open and pretty much wasn't addressed yet. Readiness is the first module of GEM, which is aimed on the prepare or incident readiness, which is essentially answering the question, am I collecting the right logs? Putting aside GEM, putting aside my SIEM, putting aside my detection rules, let's assume I have an incident tomorrow. Would I have the option to understand actually what happened? What we saw as responders, that an attack was often the first time that you notice that something critical is missing. So we try to provide it in two lenses. It's built bottom up from the inventory, but your logging coverage, both in terms of categories. So do you cover data? So if you are in AWS, do you collect S3 data events? Do you collect database audit logs on the different cloud providers that you use? So categories like control, data, network, containers, etc. And then also the coverage on things like CIS or the MITRE attack cloud metrics. Essentially, obviously, the two are correlated. If you don't collect S3 data events, your ability to respond to exfiltration deteriorates. We then take these logs and apply our detection. GEM comes out of the box with thousands of use cases that are covered with hundreds of TTPs that are building up thousands of scenarios that can be built from different building blocks, from research, publications, and most importantly, real attacks, as you can see here. Ensuring that there is coverage. Building something that has high coverage and high fidelity is a challenge. It's a mix of course, rules, analyzing sequences and related events, streams of events, and identifying the unusual and separating the unusual versus the noise that relies on some sort of cloud UEBA. We build a profile for every machine, user, instance, bucket, storage, etc. Database of usual activity, and that allows us to, one, really identify the usual versus the unusual, and also to reduce a lot of noise. We talked about being part of the workflow. So when a threat, when one of these logics is detected, we are sending it to the workflow that you have. So for some customers, it's Splunk. For others, it's QRadar. For others, use SlackOps. Some use SOAR, whether it's a Torque or a Times or a Phantom or XOR. And some are using ServiceNow and Jira. So every organization has their own flavor based on the size and based on how they work. And when they want to drill down, very much like an EDR, they go into the threat itself. And this is the icing on the cake, the way that I see it. And in the end, triage is the most important thing in a CDR. It's about response, and it's about the context that Andrew talked about, the ability to gather all these contexts. This is an example of an alert that highlights an instance that after being active for a while is suddenly doing IAM activity, which is a known pre-escalation path in the cloud. The detection itself is simply, in the end, events, like there is nothing fancy. Of course, there are profiles, etc., doing it in a way that is of value. But in the end, you get events that are triggered. The key is to understand cloud, so to parse the events to actual entities. And then there is now a Gartner category called CIRA, Cloud Investigation Response Automation. So actually asking the set of questions and conducting the investigation automatically, really shortening LTTR. So we have an instance creating a user. What did the instance do before the incident? Who created the instance? Did someone communicate to the instance at the time of the incident? Were there any policies or keys created attached to the user? Did the user do any data activities? Understanding the flow around it, what you would want the SOC analyst do if they had all the time in the universe for every alert. So that's done automatically, expanding the event to all the related events, parsing them again to entities, building a graph of all the entities involved, and building a very concise timeline of what happened from the triggering event, and then analyzing backwards the set of activities. So you can see this user connected to the instance communicated with a few other instances. There were data access to a bucket, and the user was actually attached with a strong policy and an access key. On top of the graph, the timeline, that allows you already to understand very easily what happened. You want to get some more context. Is this alert unusual? What does it mean? So you can really get a sense of the unusualness level, as well as the history of the instance, information from the API, the instance profile, different activities, seeing that indeed IAM is unusual. So all these things that would take hours, not minutes, if you wouldn't have it as something that is conducting the best, I wouldn't say the investigation, but gathering all the components of an investigation for you. And lastly, containment capabilities. So let's assume you decided you want to respond. So gathering the recommended response, the recommended response options, and actually making them accessible either through a CLI, through a ticket, or running it for you with a click of a button, from deactivating the IAM user, deleting it, so handling the outcome, or handling actually the source, the machine, isolating traffic, stopping it, etc., terminating, taking a forensic snapshot, analyzing the forensic snapshot, taking response capabilities that are in the end can be quite advanced or quite simple, and that would allow you to mitigate the threat and stop it as it occurs, very much like done today with EDRs. Cool. We'll pause here and bring it back to the audience for the Q&A. Terry?
Yes, it looks like we're back to you, Ann. Yes, Ron, we're back with you now.
What do you mean? Did you lose me?
No, you're there. We're back to the webinar slide presentation. We've left your desk.
I think I'm done, so we can move on to the Q&A.
Excellent. Thank you both for those insights and perspective on how we can be more effective in our approach to cloud security management. Gentlemen, thank you both. I want to just dive right to the Q&A because we've got just a little bit of time left. Andrew, I'd like to put the first question to you. Talk to us a bit about what you look for when you're choosing a platform for something like cloud detection and incident response. What are some of the criteria there?
Sure, that's a good question. For me, it's about detection coverage and the frequency of detection releases within the platform, and making sure that there's detection parity between the clouds, right, across the CSPs. I'd say ease of use and integration, sort of plug and play, and lightweight in the sense that you're not, doing too much or being too invasive in the organization's cloud environment. Something that can give you context, that's super important for me. And then essentially, will it provide value? So like, is it affordable from a commercial perspective? And do I see a good ROI? Like, can I see this paying for itself, essentially? Most importantly, when it comes to a vendor, right? And this is not just cloud detection and response platform specific, but one thing for me is I like to work with organizations that are collaborative and where there is a partnership. The minute you start treating me like a transaction, then I'm not going to do business with you. Sure. And that's what I like about organizations like GEM.
Excellent. Ron, a question for you. Can you talk a bit about how the GEM platform is priced, structure, that kind of thing?
Yeah, so it was, maybe we planted the seed in the challenges, but it was a question about ingestion costs. So we see, especially in the cloud, where there are a lot of logs, that ingestion cost is definitely an issue, and that's why we wanted to disconnect that. So the pricing at GEM is based on the size of the environment. So the count of resources, or the average count of resources, giving things are ephemeral. So that's how we look at that, which is much more cloud native. And since we really know the cloud logs, we are able to both, I would say, shrink the size in something that is meaningful and be efficient. And also, we built a platform in a way that is suitable for that type of economics. So it's based on the size of the environment and not ingestion.
Okay. Just to follow up there, security management often has to choose between performance and affordability. Given the vast amount of cloud security data that the GEM platform has to analyze and correlate, how do you design it where you get both high performance as well as cost effectiveness?
Yeah, so a big challenge of platforms that are doing detection in I would say in batches is they constantly query the data. So we built the platform to be based on real-time processing, which is one, faster, and two, more suitable for that type of data, and also can be more efficient if you build it right from the get-go. And then you need to support the investigation piece. So the investigation piece is built on top of a data lake. So the data is going to a data lake, but it's not used for the runtime activity. It's only used for the investigation, while the runtime is based on real-time processing, which can be definitely more efficient. So this is the play that we're doing that allows us to balance that. And we've built mechanisms that in the end are able to support it, because it's not easy, especially when you need context. So we inject context in ways that are smart to the real-time engine, and it increases the efficiency dramatically.
Thanks, Ron. Another one for you, real briefly. How much effort is required to manage the GEM platform on a day-to-day basis? Approximately how many alerts per week are you seeing generated there?
So it's in terms of challenge to manage, we invest a lot in profiling and with the ability to automatically reduce noise. And it's us together in a way that is very smart, because if you have low volume of alerts, it means that it's easy to manage. What we aspire to for large organizations is an alert a day, and for medium to small organizations is up to 3 alerts a week. So that's what we aspire to. Usually it's achieved automatically by profiles, and in some cases we do have a very granular exclusion mechanism that we can use or the customer can use. And in general, there isn't like a GEM engineer in our customer teams. It's something that is very easy to maintain. So that's it.
Thank you. Andrew, can we just let you have the last word? Tell us a bit about what you look for when you're hiring a cloud security engineer or an analyst for your team.
Sure. So 2 things, I'll keep this quick. On the technical level, I look for someone who's mastered the fundamentals. I think that's really important. And then I also most importantly, I want someone who has the right attitude, someone who's curious, someone who asks questions and has that investigative mindset and is willing to learn, etc., and can generally think outside the box, right? Like this stuff can be learned, it can be taught, but you have to want it and you have to be interested and willing to put in the work. So attitude over skill, but somebody who has the fundamentals.
Sure. Excellent. Andrew Tabona and Ron Königsberg, thank you both for sharing your expertise with us today on this Black Hat webinar. Thank you, gentlemen. That also marks the end of our Q&A. Again, I want to thank both speakers for their insights and expertise. Thanks as well to our audience for attending today's webinar, Multi-Cloud Detection and Incident Response, Practical Lessons from a Fortune 500 Security Leader, brought to you by Black Hat, Gem Security, and Informa. We'll be sending you an email link with access to this presentation on demand. You're welcome to share this with colleagues who couldn't be part of today's live presentation. On behalf of our guest experts, Andrew Tabona, Gem Security's Ron Königsberg, as well as our sponsor, Gem Security, thank you all for attending today. This has been Terry Sweeney for Black Hat. We'll see you next time.